December 7th, 1943. The outskirts of Smolensk, Soviet Union. The captured American truck sat abandoned in the frozen mud, its crew having fled when the German counterattack swept through their position. Oberfeldwebel Klaus Hermann approached cautiously, his breath visible in the bitter cold. Standard Luftwaffe procedure dictated destroying abandoned enemy equipment or leaving it behind, but Hermann, chief mechanic for a ground support unit desperately short of reliable transport, had other ideas. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Get the technical sergeant. I want this vehicle inspected before we destroy it. What Hermann and his mechanics discovered in the next hour would fundamentally challenge everything they believed about German engineering superiority and reveal truths about American industrial capacity that made Germany's defeat inevitable. The realization didn't arrive as sudden enlightenment, but as creeping comprehension that grew with each component they examined. The small data plate on the dash read Studebaker US 6, South Bend, Indiana. The Americans called it a deuce and a half. The first revelation came when they opened the hood. The engine compartment was immaculate, designed for rapid maintenance by anyone with basic mechanical knowledge. Color-coded wires, clearly labeled components, accessible parts that could be reached without specialized tools or factory-trained expertise. In 2 decades of servicing Luftwaffe ground vehicles, Hermann had never seen such thoughtful engineering for field maintenance. Every bolt was standard. Every component appeared identical to every other vehicle of its type, designed for mass production and easy replacement. The Hercules JXD inline 6-cylinder engine displaced 82 inches and produced 86 horsepower at 2,800 RPM. Not impressive by German standards, where the Opel Blitz's 75 horsepower came from a smaller displacement. But the engineering philosophy behind the Studebaker was revolutionary in ways that transcended raw specifications. This engine wasn't built to be perfect. It was built to be simple, reliable, and above all, producible in massive quantities. A mechanic with minimal training could service this engine with basic tools, no specialty wrenches, no complex procedures requiring factory certification, no intricate adjustments demanding precision instruments. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Americans had apparently designed this vehicle expecting that farm boys and factory workers with perhaps weeks of training would need to maintain it under combat conditions thousands of kilometers from any depot. By December 1943, the contrast between American and German military vehicle philosophy had become stark to anyone paying attention, though few Wehrmacht commanders wanted to acknowledge what the evidence revealed. America would produce over 640,000 jeeps during the war. Germany would manage just over 50,000 Kübelwagons. More troubling still was what this disparity represented. The Studebaker embodied American manufacturing thinking at its finest. Standardized, simplified, designed for mass production by semi-skilled workers using interchangeable parts that required no hand-fitting or specialized knowledge to install. Hermann's assistant approached as the mechanics continued their inspection. "Well, can we use it?" Hermann looked up, choosing his words carefully in front of junior personnel who still believed the propaganda about inevitable German victory. "This vehicle is remarkable. It's designed by someone who understands field conditions better than our own engineers apparently do." One officer frowned, defensive about suggestions of American superiority. "German engineering is the finest in the world. Everyone knows this." Hermann didn't argue directly. He simply gestured to the transfer case and 6-wheel drive system. "Look at this configuration. 6 wheels, all driven. A single lever engages the front axle. 1 lever. Our Opel Blitz trucks, which are excellent vehicles, only drive the rear wheels. In mud, in snow, in sand, that limitation proves devastating. This American truck powers all 6 wheels whenever the driver chooses. The system is so simple that an uneducated conscript could master it in minutes. The Luftwaffe's primary heavy vehicle, the Opel Blitz 3-ton truck was an excellent machine in many respects. It had been designed with typical German attention to detail and precision engineering. It was adequately powered, reasonably fuel-efficient, and its overhead valve straight-six engine represented modern automotive thinking. But it had one critical weakness that no amount of German engineering sophistication could overcome. It was rear-wheel drive only. In the mud of Russia, the sands of North Africa, the mountains of Italy, that limitation proved devastating. German supply columns regularly became stuck, requiring hours of labor to extract vehicles from mud or sand. Entire offensives had been delayed because trucks couldn't reach forward units with fuel and ammunition. The Studebaker, by contrast, could power all 6 wheels whenever needed. The system was so elegantly simple that it seemed almost crude to German engineers trained to admire complexity. But crude American design worked better than sophisticated German precision in the conditions where wars were actually fought. The mechanics continued their inspection through the afternoon, as weak winter sunlight filtered through the overcast sky. The suspension used simple leaf springs on all axles, crude compared to sophisticated German designs, but infinitely easier to repair in the field. A broken leaf spring could be replaced by a mechanic with a wrench and a jack. No special tools, no factory precision required. The electrical system was basic but robust, using standardized components that could be cannibalized from any other American vehicle. The fuel system could run on almost any grade of gasoline without modification or adjustment, a feature that seemed impossible to Germans accustomed to engines that required specific octane ratings and careful carburetor tuning. Most troubling of all was the weight distribution and construction philosophy. The Studebaker weighed approximately 5,700 pounds empty, compared to the Opel Blitz's 4,600 pounds. German engineers would have considered this excess weight a fundamental flaw, reducing performance and increasing fuel consumption. But Hermann recognized the method behind what appeared to German thinking as wasteful design. That extra 1,000 pounds translated to durability, beyond anything German military vehicles achieved. The frame was overbuilt, designed to handle punishment that would destroy lighter vehicles. The axles were reinforced beyond what immediate specifications required. The transmission and transfer case featured design margins that allowed the truck to carry loads far exceeding its rated capacity. The Americans had decided that reliability under abuse and overloading mattered more than optimal efficiency under ideal conditions. They had built a vehicle expecting it to be misused, overloaded, driven by inexperienced operators, and subjected to conditions no engineer would approve of, and then engineered it to survive anyway. This wasn't the American incompetence that Goebbels' propaganda films had promised. This was engineering focused on reality rather than theory, on practical results rather than impressive specifications. The unit brought the Studebaker back to their forward maintenance facility as darkness fell. Over the next 5 days, mechanics conducted exhaustive tests under Hermann's supervision. They drove it through deep snow, where Opel Blitz trucks required chains and careful driving. They loaded it beyond its rated capacity with spare parts and equipment. They subjected it to abuse that would have crippled most German vehicles within hours. The Studebaker absorbed everything without complaint. In deep snow and mud, where rear-wheel drive vehicles required constant attention from crews with shovels, the Studebaker simply powered through when all 6 wheels were engaged. The low-range gearing allowed it to crawl over obstacles at walking speed with torque that German trucks couldn't match despite their reduction gears and careful engineering. The front-mounted winch, powered by the engine through a power takeoff, could extract the truck from situations where German vehicles would have been abandoned. Word spread through the German units in the sector. The Americans had a vehicle that outperformed the Wehrmacht's equivalents in almost every meaningful way. Officers and mechanics from other units found excuses to visit and examine it. The reactions followed a predictable pattern. Initial skepticism born from years of propaganda about German technological superiority, followed by grudging respect as they examined the vehicle's features, then dismay as the implications became clear. One supply officer who had worked in German automotive plants before being conscripted spent an afternoon studying the vehicle with Hermann. His assessment was blunt, spoken quietly where junior enlisted men couldn't overhear. This represents a fundamental difference in approach. We Germans build vehicles to achieve engineering perfection according to specifications developed in peacetime. The Americans build them to be manufactured in massive quantities and maintained under terrible conditions. In total war, that matters infinitely more than our precision. He explained to the assembled mechanics what this difference meant for Germany's prospects. Look at this engine block. It's cast iron, not machined to fine tolerances like our engines. The Americans sacrifice a small amount of performance and efficiency for massive gains in production speed and reliability. They can train a semi-skilled worker to assemble one of these engines in a fraction of the time it takes our craftsmen to build an Opel or Mercedes engine. Now multiply that efficiency across every single component. He pointed to the stamped metal body panels and simple fasteners. These panels are crude compared to our vehicles if you examine them closely, but they can be produced by the thousands in factories that previously made household appliances or civilian trucks. The Americans have mobilized their entire economy for war production. Every refrigerator factory, every washing machine plant, every commercial vehicle manufacturer, all converted to military production, using methods designed for mass manufacturing. We cannot match this capacity. We never could. The mechanics fell silent. He had articulated what many had begun to suspect, but few dared voice openly. Germany's philosophy of quality over quantity, precision over adequacy, made sense in peacetime competition. But in total war against enemies with vastly superior industrial capacity, the American approach of adequate products delivered quickly in overwhelming numbers was proving devastatingly effective. Hermann spent that evening writing a detailed technical report, documenting every aspect of the Studebaker's design, noting both its strengths and its few weaknesses. The report made its way up the chain of command through Luftwaffe Technical Services, one of thousands of such documents produced by German technical intelligence throughout the war. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Similar reports were flooding into Wehrmacht's headquarters from every front where German forces encountered American equipment. German mechanics and engineers were encountering American vehicles with increasing frequency as Lend-Lease deliveries to the Soviet Union reached their peak, and the technical assessments were uniformly troubling. The Americans were outproducing Germany by ratios that seemed impossible until you examined the actual evidence. In late 1943, Wehrmacht intelligence had commissioned comprehensive studies of Allied vehicle production. The results confirmed suspicions that high-ranking officers had been reluctant to believe. American factories were producing military vehicles at a rate exceeding 15,000 per week. Ford's Willow Run plant alone was completing a B-24 Liberator heavy bomber every 63 minutes at peak production. American shipyards were launching Liberty cargo ships faster than German U-boats could sink them, using prefabrication and welding techniques that reduced construction time from 8 months to 6 weeks. The statistics revealed a sobering truth that made Germany's ultimate defeat a matter of arithmetic. America's 1943 military vehicle production exceeded the total combined production of Germany, Italy, and Japan, and American production was still accelerating, while German production faced increasing constraints from strategic bombing and resource shortages. The captured Studebaker became something of a prized asset in Hermann's unit. Officers competed for permission to use it for forward reconnaissance and supply runs, trusting its reliability more than their own vehicles. Mechanics studied its design features, discussing among themselves how German engineers might have built vehicles differently if they had prioritized field maintenance and mass production over precision specifications. When parts wore out or components failed, replacement parts were sometimes available from other captured American vehicles. Everything was genuinely interchangeable, not just theoretically so. A part from one Studebaker fit every other Studebaker perfectly, without hand-fitting or adjustment. This level of standardization remained largely theoretical in German military vehicle production, where each manufacturer introduced subtle variations that prevented true parts interchangeability, even between supposedly identical vehicles. By early 1944, Wehrmacht units had captured dozens of Studebakers on the Eastern Front. German mechanics formed informal networks, sharing maintenance knowledge and scrounging parts from destroyed vehicles. A black market emerged, where a working Studebaker could command resources far exceeding its theoretical value, because everyone who had used one recognized its superiority for winter operations and difficult terrain. The Luftwaffe ground units particularly valued captured Studebakers because they needed to move equipment and personnel rapidly to support air operations. Reliability mattered more than specifications. A truck that broke down between the airfield and forward positions was useless, regardless of how impressive its engineering had been. A simple truck that worked consistently under terrible conditions enabled operations that sophisticated but unreliable vehicles could not support. Hermann and his mechanics maintained their captured Studebaker through the winter of 1943 into 44. They learned its quirks and characteristics. The Hercules engine could indeed run on almost any gasoline, though it preferred higher octane. The front axle engagement could be tricky in extreme cold, until you learned the technique. The transmission's synchronized gears made shifting smooth, but required different timing than German transmissions. But these were minor issues. The fundamental reliability never wavered. The truck simply worked, through temperatures that dropped to -40 degrees, through mud that swallowed German vehicles to their axles, through overloading that would have broken lesser vehicles. The Studebaker continued operating month after month with maintenance requirements far below what German trucks demanded. One night in March 1944, Hermann sat in his quarters writing another report for technical services. His commanding officer had requested detailed comparisons between the Studebaker and German equivalent vehicles. Hermann chose his words carefully, knowing that excessive criticism of German equipment could be interpreted as defeatism. The American Studebaker US-6 truck represents automotive engineering philosophy fundamentally different from German practice, he wrote. Where German vehicles are designed to achieve optimal performance under ideal conditions with maintenance by trained specialists, the American vehicle is designed for adequate performance under terrible conditions with maintenance by minimally trained personnel. The Studebaker accomplishes this through generous design margins, component simplicity, and systematic standardization that enables rapid production and field repair. The six-wheel drive configuration provides traction advantages that our rear-wheel drive trucks cannot match. The front-mounted power winch enables self-recovery in situations where German vehicles would be abandoned. The engine demonstrates exceptional tolerance for poor fuel quality and irregular maintenance. Most significantly, every component appears designed for mass production using semi-skilled labor and for field replacement without specialized tools or training. He paused, considering whether to include his next observation. Then he wrote it anyway, knowing it needed to be said. American industrial capacity enables production of these vehicles in quantities that dwarf German output. Our technical superiority in engineering specifications matters little when the enemy can field 10 trucks for every one we produce. Reliability and quantity together create operational advantages that superior German engineering cannot overcome. He sealed the report and sent it up the chain of command. He never received any response or acknowledgement. By April 1944, such reports were common enough that they no longer generated discussion at higher levels. Everyone with eyes could see that Germany was losing the industrial war, though few dared say so explicitly. Spring brought the muddy season, the dreaded Rasputitsa that turned Russian roads into impassable rivers of mud. German truck columns became immobilized for days at a time as vehicles bogged down and couldn't be extracted. Horses, which still provided 80% of Wehrmacht logistics, couldn't pull loaded wagons through mud that came up to their bellies. Supply operations ground to a halt across entire army sectors, but the Studebaker, with its 6-driven wheels and generous ground clearance, continued operating. Hermann watched it crawl through mud that had stopped an entire column of German trucks. The American vehicle simply kept moving, its tires churning through mud that would have immobilized anything else short of tracked vehicles. This single observation, repeated across hundreds of German units that spring, taught lessons about the decisive importance of reliability and design philosophy that transcended any specific technical comparison. The Wehrmacht's logistical situation had been dire throughout the war, but by mid-1944 it had become catastrophic. Approximately 80% of German divisions still relied on horse-drawn transport for logistics. The German army had entered World War II with 514,000 horses and would eventually employ over 2.7 million horses and mules during the conflict. At any given time, approximately 1.1 million horses served in German military operations. This wasn't a deliberate choice reflecting superior logistics philosophy. It was necessity born from Germany's inability to produce enough motor vehicles to fully mechanize its forces. German industry built approximately 130,000 Opel Blitz trucks between 1935 and 1944, representing by far the largest single-vehicle production program. That entire output would barely equal 6 months of American Studebaker production for Lend-Lease alone. The scale disparity made Germany's defeat mathematically inevitable, regardless of tactical prowess or strategic brilliance. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The contrast between German and American capabilities became impossible to ignore as reports accumulated through mid-1944. In June, the Western Allies landed at Normandy, with logistical capacity that dwarfed anything Germany had achieved during its most successful offensives. The invasion fleet included 6,000 ships and 11,000 aircraft supporting 150,000 men in the first wave alone. Within weeks, millions of Allied soldiers would be fighting in Western Europe, all supplied by a production base that created equipment faster than the Wehrmacht could destroy it. German prisoners captured after D-Day reported their astonishment at Allied motorization. They had expected to see some trucks and vehicles, having been told that Americans relied heavily on machines, but the sheer scale exceeded anything German propaganda had prepared them for. Truck after truck rolled off landing craft, tank after tank, jeeps by the hundreds, self-propelled artillery, amphibious vehicles, all supported by supply systems that delivered fuel, ammunition, food, and spare parts with efficiency German logistics could never approach. "Where are the horses?" captured German soldiers asked their guards, genuinely confused. The question revealed how completely German forces still depended on animals for transport, despite propaganda about mechanized warfare. British and American armies had fully motorized their logistics. Every division moved entirely by truck. Horses existed only in specialized roles or among civilian refugees. The disparity in mobility meant Allied forces could sustain offensive operations that German forces could not match or counter. Hermann's unit retreated westward through the summer of 1944 as Soviet offensives shattered German defensive lines. The Studebaker came with them, now carrying equipment and wounded personnel as the Luftwaffe's ground organization collapsed under overwhelming pressure. German trucks broke down constantly. Parts were unavailable. Fuel was scarce. Mechanics struggled to keep even minimal numbers of vehicles operational. The Studebaker kept running, month after month. Through retreats and emergency redeployments, through fuel shortages, where it demonstrated its ability to run on almost anything combustible, through mechanical abuse that would have destroyed most vehicles. In August 1944, RAF bombing devastated the Opel Brandenburg plant that produced Blitz trucks. The facility, which had been producing about 2,600 trucks monthly, went offline. Production was shifted to Daimler-Benz facilities in Mannheim, disrupting supply chains and reducing output. German truck production, already inadequate, fell further behind requirements. Shortages of spare parts meant broken vehicles couldn't be repaired. Shortages of fuel meant serviceable vehicles couldn't operate. By autumn 1944, Wehrmacht logistics had degraded to crisis levels across all fronts. Units reported that 70% or more of their motor vehicle losses came from mechanical failure and abandonment rather than enemy action. Trucks were left behind during retreats because they couldn't be repaired and couldn't be transported. Artillery pieces were abandoned because there were no trucks to tow them and not enough horses to pull them. Even panzer divisions, supposedly the Wehrmacht's most mobile formations, faced severe transport shortages that limited their operational effectiveness. Hermann understood by then that Germany would lose the war. The evidence was overwhelming to anyone willing to see it clearly. American industrial capacity had decided the outcome before the first shot was fired. German tactical skill, operational expertise, and individual courage couldn't overcome the arithmetic of production. One Studebaker truck represented what America could build in quantity. Germany couldn't match it. That simple fact, multiplied across every category of military equipment, made defeat inevitable. The only questions remaining were how long until the end came, and how much more destruction would occur before Germany surrendered. November 1944 brought news of Hitler's planned offensive in the Ardennes, what would become known as the Battle of the Bulge. The operation relied heavily on capturing American fuel supplies because Germany no longer possessed sufficient petroleum reserves to sustain major armoured operations. Wehrmacht planners calculated that panzer divisions would run out of fuel within days unless they could seize Allied supply dumps. More troubling to experienced logistics officers were reports of Operation Greif, Otto Skorzeny's commando operation using captured American equipment. German soldiers were being equipped with captured American vehicles, primarily jeeps and trucks, along with American uniforms and forged identification documents. Their mission was to infiltrate Allied lines, cause confusion, and capture key bridges before they could be demolished. If even Skorzeny, Hitler's favourite commando who had rescued Mussolini from Italian captivity, was reduced to depending on captured American vehicles because German vehicles were insufficient for the mission, that revealed everything about the venture, Wehrmacht's material situation. The fact that German special operations required American equipment to succeed demonstrated which nation had built vehicles appropriate for modern warfare. The Ardennes offensive began December 16, 1944. Initial German attacks achieved tactical surprise and made significant gains, but within days, the operation began collapsing not primarily from American resistance, though that proved fierce and effective, but because German forces ran out of fuel. Panzer divisions abandoned their tanks when fuel trucks failed to arrive. Infantry divisions resorted to horse-drawn transport because motorized logistics had completely collapsed. American fuel dumps that German units had expected to capture were either destroyed by retreating Allied forces or defended successfully. Without captured fuel, German armoured spearheads became immobilized. The most technologically advanced tanks Germany possessed sat useless beside roads because they had no gasoline. By January 1945, the German attack had been contained and reversed. American forces counterattacked with the overwhelming material superiority that characterized all Allied operations by that point in the war. Hermann's unit had retreated into Germany itself by February 1945. The Studebaker was still operational, now one of the few reliable vehicles the unit possessed. Most German trucks had been abandoned during the retreats. Spare parts were completely unavailable. Fuel allocations had been cut repeatedly. The unit's remaining Opel Blitz trucks barely functioned, kept running through desperate improvisation and cannibalization. The American truck continued working with minimal maintenance. Its Hercules engine ran on whatever fuel they could scavenge. Its simple design allowed repairs with basic tools and improvised parts. When a fuel line cracked, they replaced it with rubber tubing from a destroyed aircraft. When a tire failed, they installed a wheel from an abandoned Wehrmacht truck that happened to fit. The Studebaker absorbed these indignities and continued functioning. One afternoon in March 1945, an American P-47 Thunderbolt fighter bomber made a strafing run on the column. The Studebaker took several .50 caliber hits through the cargo bed and one through the hood. Hermann inspected the damage after the attack passed. The .50 caliber round had punched through the hood, struck the engine block, and ricocheted off without penetrating. The engine had a gouge across one cylinder head where the bullet had scraped across the cast iron, but the engine continued running. German vehicles would have required complete engine replacement after such damage. The Studebaker's overbuilt construction had literally saved it from a direct hit. Hermann patched the bullet holes with sheet metal and continued using the vehicle. By April 1945, Germany's collapse was complete and undeniable. Had encircled Berlin. American and British forces drove deep into Germany from the west. Italian partisans had executed Mussolini. Hitler committed suicide in his bunker. On May 8, 1945, Germany surrendered unconditionally. Hermann's unit was captured by American forces in Bavaria. The Studebaker was among the vehicles in their convoy when they surrendered. An American motor transport sergeant examined it, noting the German markings painted over the original American star. "You guys have been using this," he said in passable German, amused rather than angry. Hermann nodded, too exhausted for anything but honesty. "It was the best vehicle we had, more reliable than our own trucks." The American sergeant laughed. "Yeah, Studebakers are good trucks. Russians love them. We built about 200,000, sent most of them to the Soviets through Lend-Lease. They're still running convoys from Persia to Moscow with these things." Hermann felt something collapse inside him at those numbers. 200,000 of this single truck model. Germany had built 130,000 Opel Blitz trucks total across 10 years of production. America had built twice that many Studebakers in 4 years, just for export, while also building hundreds of thousands of other vehicles for their own forces. The scale of American production had been beyond anything German intelligence had accurately reported. Or perhaps the reports had been accurate and the leadership had simply refused to believe them. The journey to the prisoner of war camp provided Hermann's first extended view of American logistics operating at full capacity. Convoys of trucks stretched for kilometers along every major road. Tank transporters carried disabled vehicles to repair depots. Supply dumps covered hectares of land with organized rows of equipment, fuel, ammunition, food, medical supplies. American soldiers operated this logistical machine with casual efficiency that would have been impossible in the Wehrmacht. Young men barely out of their teens performed maintenance with speed and confidence, born from good training and abundant resources. Tools were plentiful and readily available. Parts were delivered without requisition delays that had plagued German logistics. Every vehicle used the same basic components, allowing mechanics to service any vehicle without specialized knowledge. At the processing center in Mannheim, Hermann watched American motor pool sergeants service a fleet of vehicles with systematic efficiency. The motor pool contained dozens of trucks of multiple types, jeeps, command cars, and specialized vehicles. Young American soldiers performed maintenance that would have required multiple shifts and specialized personnel in German service. One American sergeant noticed Hermann watching and walked over. "You a mechanic?" he asked in heavily accented German. "I was." "Luftwaffe ground support vehicle maintenance." The sergeant grinned. "Well, war's over for you now, but I bet you got questions about our stuff. Come on, I'll show you around. Can't hurt anything now." What followed was an educational afternoon that crystallized everything Hermann had suspected about American automotive philosophy. The sergeant walked him through the motor pool, explaining American maintenance thinking with unguarded honesty that German propaganda had never prepared him for. "See? The thing is, we design everything so any farm boy can fix it," the sergeant explained. "Most of our guys never saw a vehicle engine before basic training, maybe drove a tractor back home if they were lucky. So we make it simple. Color-coded wires so you can't connect them wrong. Standard bolts so you only need a few wrench sizes. Everything labeled in plain English. We got manuals written for 8th grade reading levels. The idea is that if something breaks, anyone can fix it without calling in a specialist or waiting for a factory-trained mechanic." Hermann examined a disassembled truck engine on a workbench. Every component was clearly marked. The maintenance manual contained detailed illustrations and step-by-step instructions that could be followed by someone with minimal mechanical knowledge. The contrast with German technical manuals, which assumed extensive prior training and often referenced specialized procedures, was stark. "How many of these trucks do you produce?" Hermann asked, though he suspected he didn't want to know the answer. The sergeant shrugged casually. "Hell, I don't know exact numbers, but thousands every week from what I hear. We got so many trucks that if one breaks down, we usually just grab another one instead of fixing it immediately unless we're short on vehicles. Field mechanics do routine maintenance, but serious repairs get sent to depot level. The broken truck gets rebuilt there and sent back to the pool, keeps the supply flowing, thousands every week." The number seemed impossible, yet the evidence was everywhere. This single, motor pool in a forward area contained more vehicles than entire German divisions had possessed at full strength. And this scene was being repeated at camps and depots across liberated Europe, across Britain, across North Africa and Italy, across the Pacific Theatre. American productive capacity operating at levels Germany had never approached. The sergeant continued the tour with evident pride in American logistics. GMC trucks capable of hauling loads that would require 2 German vehicles. Dodge weapons carriers built in quantities that made German equivalents seem like hand-built rarities. Tank transporters that could move armor without wearing out tracks or final drives. "The thing is, we learned from the last war," the sergeant explained. "We build everything with common components where possible. A bolt from a Jeep fits a truck, fits a half-track. Same with electrical parts, hydraulic systems, filters, lots of stuff. Makes logistics simple. Instead of needing 10,000 different parts, we need maybe a couple thousand different items and we produce them by the millions, ship them wherever they're needed." This was the fundamental insight that German manufacturing had never fully grasped or implemented systematically. Component commonality wasn't just about production efficiency. It was about creating a logistical ecosystem where any part could be used anywhere, any mechanic could service any vehicle, and the entire system reinforced itself through standardization. The American approach eliminated the nightmare of incompatible parts and specialized knowledge that had plagued German logistics throughout the war. The camp at Bad Kreuznach held thousands of German prisoners awaiting processing and eventual repatriation. Hermann volunteered for the motor pool when American commanders asked for skilled mechanics. They needed workers desperately. Most of their mechanics were being redeployed to the Pacific Theatre, where the war against Japan continued. For the next 6 months, Hermann worked alongside remaining American soldiers, maintaining the vehicles that kept the occupation running. American maintenance philosophy proved as enlightening as American production capacity had been sobering. Americans approached vehicle maintenance with direct practicality, focused on results rather than procedural perfection. When something broke, they fixed it quickly with whatever was available. When parts weren't immediately available, they improvised solutions using parts from other vehicles or fabricated replacements. When a vehicle proved unrepairable given available resources, they cannibalized it for components and requested a replacement, which typically arrived within days rather than weeks. Hermann observed these techniques closely, comparing them mentally to German practices. German mechanics had been trained to maintain vehicles to factory specifications, requiring specialized tools and proper procedures for every operation. American mechanics were trained to keep equipment running by any means necessary that worked. In peacetime conditions with abundant resources, German methods produced superior results and longer vehicle life. In wartime chaos, with limited resources and urgent operational needs, American methods proved vastly more effective. The motor pool at Bad Kreuznach processed hundreds of vehicles monthly. Trucks came in for routine maintenance, received service in hours rather than days, and returned to operational status. The efficiency came from parts abundance, component interchangeability, and systematic procedures that didn't require specialized expertise. When a part needed replacement, the parts warehouse had dozens in stock. When a tool was required, the tool room provided it immediately. When a vehicle was beyond economical repair, another one took its place within days. Hermann befriended an American soldier who had worked for Studebaker before the war. The American proved knowledgeable about the automotive industry and willing to discuss it with a German who had nothing left to hide and nothing to gain from deception. Before the war, I worked at the South Bend plant where we built the US-6, the American explained during a break one afternoon. That's Studebaker's main facility in Indiana. We were producing about 4,000 trucks a month by 1942. The whole plant ran on assembly line principles that Henry Ford pioneered. You break down complex manufacturing into simple, repeatable steps. The arithmetic was staggering even before the American continued. 4,000 trucks per month from one plant. That was more than some German manufacturers produced in entire years. And that's just cargo trucks, the American continued. We were also building Wright Cyclone engines for B-17 bombers at the same plant. Over 60,000 engines during the war. Plus, we supplied engines and components to other manufacturers. The whole thing worked because of interchangeable parts and standardized processes. How is such production possible? Herman asked, though he was beginning to understand the answer. Mass production principles perfected over decades of civilian manufacturing, the American explained. You don't need skilled craftsmen if every worker does one simple task repeatedly. A kid fresh off the farm can be trained in a couple weeks to install one specific component in one specific location. You have 1,000 workers each doing their specialized task, and you get massive output. Plus, we designed the trucks for manufacturability from the start. Every part had to be simple to make, simple to install, simple to replace. This was the fundamental difference that explained everything. German production relied on skilled craftsmen building quality products in moderate quantities, using traditional methods adapted from peacetime manufacturing. American production relied on systematic processes using semi-skilled workers, building adequate products in massive tenteres quantities using methods specifically developed for wartime mass production. The American approach sacrificed some individual quality for overwhelming quantity. In total war, quantity combined with adequate quality proved decisive. The American continued with information that would have been classified months earlier, but now seemed merely historical. Same thing with all our trucks. GMC built the CCKW Deuce and a Half primarily for our own army. International Harvester built their version for the Navy and Marines. Studebaker built the US-6 mostly for Lend-Lease to the Soviets and British. All of them shared common components where possible. A Studebaker transmission could go into a GMC truck with minor modifications. Electrical systems were standardized. Tires were interchangeable. Maintenance procedures were similar across all models. That meant if one plant got bombed or had production problems, others kept building trucks. Parts from any manufacturer fit vehicles from other manufacturers. Every mechanic learned similar procedures that worked on multiple vehicle types. Herman thought about the Wehrmacht's vehicle inventory scattered across Europe and Russia. Dozens of different truck types from different manufacturers, each with unique parts and maintenance requirements. Kübelwagens from Volkswagen, Opel Blitz trucks in multiple variants, Mercedes vehicles, captured French and Czech vehicles pressed into German service. The logistical nightmare of supporting dozens of incompatible vehicle types with parts that rarely interchanged. German logistics had been a disaster of incompatible systems and scarce parts from the beginning. American logistics were streamlined through standardization and component commonality that made everything simpler. The real genius, the American said, is that we designed for manufacturability from the start. When the Army put out requirements for the US-6 back in '40, they gave companies tight deadlines. Everything had to be simple to manufacture, simple to maintain, simple to repair. No sophisticated technology that required special skills or tools. Just solid engineering applied to practical problems. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.